Welcome back everyone to theCUBE's live coverage here in San Francisco, California for Databricks' Data Plus AI Summit. I'm John Furrier, host of theCUBE. Full day of wall-to-wall coverage. We had the founder of Databricks in, we've had some of their top showcase customers and partners that were on the stage, some senior distinguished engineers, the builders behind the tsunami of greatness that came out this keynote. A lot of new stuff, directionally super relevant, just getting off the ground, now publicly released. And one of the big products was Agent Brick. We have the chief AI scientist, John Furrier, CUBE alumni on Databricks. He was holding back a couple months ago on theCUBE at the NYSC as we were chatting about model integration, how to pull us all together. His baby has now been released out in the wild. Jonathan, great to see you. Thanks for coming on theCUBE.
Thank you for having me back, this time on our home turf.
Super excited, you got a big smile, you got a spring to your step. Finally, your work you've been working on is out there. Your Slack's blowing up, customers are calling you. Man, how does it feel?
It's a good day. I mean, today is always, I don't know, what's the right way to put it? When you're a researcher, you never know what's going to work and what's not, and 80% of things fail along the way. So when I look back over the past year, there are a few things I'm really proud of, and a lot of failures. As a researcher, everything you look back on is failure.
Yeah.
And it's days like today where it all kind of hits you all at once. Wow, we accomplished a lot in the past year, and the 20% that worked is shipping and making a big impact for our customers. There's no better feeling.
So the core product that obviously stole the show, obviously the whole show was pretty strong. The evolution of the platform has been, as we've been documenting, pretty strong. But the real aha moment I thought, was the vibe coding piece, which kind of shows at the front end. There's all going to be all kinds of automation on the front end. But the real magic is going to be happening at this data operating system layer, I call it. And that is where the complexity is abstracted away to make things as simple as print the document. Magic happens, but a lot's going on. To make agents work is hard. The Agent Brick, which was the big news, was impressive. So take us through, what is that? What is it? What is the Agent Brick? What is the Gen AI technology? What was released and what's under the hood?
Well, I mean, the first thing I want to say is, you missed one of the biggest announcements, which was Lakebase. We have an OLTP database now on Databricks, and that's going to be a huge deal for powering all these agents. I just want to highlight that because, I think about Agent Bricks all the time. It's boring for me at this point. I'm excited about Lakebase. This is new for me. But when it comes to Agent Bricks, the way I think about it is, I and everybody on our team, our AI engineers, our AI researchers, we've been helping customers build agents for the past year. And we've learned a lot along the way. That's how you build a good product. Yeah. You start by making your customers successful, and you find patterns, you generalize those patterns, and Agent Bricks is really the generalization of the best practices, the verticals that we saw, the styles that people used, the techniques that we saw work the best, all in one product. And it reflects kind of philosophically how we think people should build agents. It reflects what worked and what didn't work. And honestly, I'm most grateful to the customers who were willing to work with us before this existed and help us figure out what we should be doing in the first place. But now it's ready for prime time. I
mean, pioneers who make things happen always have that working backwards from the customer. And then again, as you pointed out, synthesize the patterns. What were some of those patterns? What did you guys glean through the data and some of these engagements that brought you into the zone to kind of focus in on that piece? What was the key pattern? What was happening? What did you guys see that was repeatable? What was the friction that you took away from that?
So there are really two patterns that are most near and dear to my heart that I worked on personally. The first was evaluation first. When you saw that demo earlier today, our product manager who oversaw the entire project, she did this great demo of building an agent. But when she opened up Agent Bricks, the first thing she did wasn't, create agent. It was create evaluation. How do we measure? How do we know the agent's going to be good? How do we ensure the agent's going to be reliable? And this has been something I've been obsessed with for the past year. I had a bunch of customers come to me and they said, we built this great agent. Now we don't know whether it's working well, and we don't know whether we can upgrade from Claude 3.5 to Claude 3.7 or what have you. And the right answer there is, well, you got to measure. And you can't improve what you can't measure. And I think in general, I know everybody said that 2025 is going to be the year of agents. For me, 2025 is going to be the year of AI engineering as opposed to AI demos. Yeah. An AI demo you can slap together, you can show to your CEO, it'll have some cool behaviors and everybody will be excited. That's not how you get into production. AI engineering is building a system that is carefully calibrated to solve a particular problem. You can measure how well it's solving that particular problem. When it doesn't work the way you want it to, you add more measurement to make sure you never see that problem again. It's just like software engineering.
Yeah.
Nobody just builds some code and ships it. You build tests, you build code to meet the tests, you debug it. When you find a bug, you build a test to catch the bug, you deploy it in the wild, you find more bugs, you do the same thing. And that's software engineering. There's a practice to it, there's a science to it. And this is a year when AI is going to become AI engineering, and that means reliability first and eval first.
I love that AI engineering vibe because I think that it's so right on.
It's not a vibe. We're done with vibes here.
Okay.
This is now engineering.
Okay, hold on. Let me rephrase. I love the vibe of AI engineering, and I love that AI engineering has to get done because the systems that run it is a system. It's not like an app. So you have a lot of moving parts. On the other hand, I'm hearing evaluation, I think HR, performance review. Of course, labor, worker. So, I mean, those are two things going on. You got a human thing kind of concept, evaluation, are you performing up to task? Are you drifting on the job, sleeping on the job, so to speak? And then the engineering of how do you make it work? Take me through first the engineering piece. What does AI engineering mean to you when you think, okay, I got an agent, I got a workflow, I got my deterministic pipeline built. What happens next? What is the process? What happens on that evaluation? How do I think about engineering it as a discipline, like as a job?
Yeah, so I think the way that I think about this is a metaphor to software engineering. We don't build big pieces of software in a big monolithic way, ship them and go, the vibes are good on this web app, or the vibes are good on the Lakebase. Can you imagine if someone built software that way? They'd lose their job.
Good vibes on that financial transaction. Oops.
Exactly. But there are other key aspects to software engineering that we have to manage complexity. And I guess one other big aspect of software engineering is more than one person has to be able to work on it at the same time and not step on each other's toes. If someone makes a change here, it can't break everything over there. We have modularity, we have abstraction, we have ways of setting boundaries and figuring out how to evaluate and make sure one piece, one module, one agent in this case, is behaving the way you want it to, and then you use our multi-agent AI builder to put things together with everything else. And so, that's the practice of software engineering. We build tests, we build specifications, and then we make sure the software meets that specification. That's what, Agent Bricks leads you through that process. In software engineering, we don't really have to do that anymore. It's second nature to everybody. But for now, I want to kind of impose that pattern on you. I want to make you do it the right way, the careful way, because you're going to be a lot happier and you're going to get to production faster if you take those extra steps at the beginning. And when it comes to that evaluation, I think the trickiest part about AI evaluation is it's not like software, where in software you can go and look at a particular piece of code and you can say, here are all the possible things it might do, all the possible inputs, all the possible outputs. Let me account for every case. It's very deterministic. It's very discrete in how it behaves. AI is kind of a little bit unpredictable, non-deterministic, fuzzy, and we need fuzzy evaluation to make up for that. That's where LLM judges come in. You have an LLM that evaluates whether the LLM is working well, and to do that you have to make sure the LLM judge knows what you're trying to do, knows how to measure it. And the most important part for me, the LLM judge, it's not about telling the LLM judge what to do properly. It's really about, does the LLM judge agree with a human judge? If you were to have a human rate every single behavior of your agent, what would a human say? And does an LLM judge agree with that human? And in fact, what would 3 humans say? Do the 3 humans agree with each other? And then you can start to ask, did you build an LLM judge that agrees with the humans? It's not about the prompt you give, it's about the behavior. Everything about AI is behavioral. The last thing I'll say on this, because I think I'm obsessed with this right now.
It's awesome.
Is that I've seen this amazing thing when people are building agents. Let's say 2 people want to build an agent together. At the beginning of the process, they might think they agree about what the agent's supposed to do, but actually secretly disagree. They just may not know that. And, in software, if 2 people disagree about that, it can happen, but you write a design doc, and maybe you start to agree there. And then you build, wireframes for your system, and you can still maybe disagree there. Once you have code, it is physically impossible to disagree about what code does. It's objective. In AI, there's no moment like that. There's no such thing as code. A prompt is not code. Reasonable people can interpret a prompt differently. And in fact, an AI can interpret the prompt differently from 2 people. And so I've seen cases where 2 humans have worked together to build an agent, they've deployed the agent, and they still don't fully agree about what the agent is supposed to do. The only way to constrain that is to build evaluations, build tests, show real behaviors, and make sure the humans agree on the behaviors.
This, again, I love that, great description. So talk about the judges, because reinforced learning with human feedback is a huge part of this. but you've gone a step further. You've expanded the human piece in the LLM evaluator, the judge. Talk about under the covers. What'd you do to make that happen? How is that possible? How do you become the arbiter of agreement, alignment? How do you get that kind of alignment?
So the nice thing is the answer is statistics. And there's a lot of statistics going on underneath Agent Bricks that's powering how we build those LLM judges. So the first part is you need to get enough examples. One example is not going to cut it. The next part is ideally you have multiple humans look at those examples, and we have a lot of products in our agent eval product, our labeling sessions product, specifically to help multiple humans come to agreement. And then once you have that, there are correlation metrics you want to look at between the humans and the judge. Now all that is under the hood. That's not stuff you have to think about. Again, it's a pattern that we saw and we generalized. But the bottom line is there's a science to this. I learned that science over the past year. We have experts on my team who taught me a lot over the past year about how to do this. And then once you have that judge isn't just how you measure a system. That judge is also how you guide a reinforcement learning process that can train an agent to behave the way you want it to. And this is the most exciting part for me, the part that I didn't talk about last time because I couldn't. To train an agent where you don't need any labels. All I need is a bunch of example inputs to your system, questions that you might ask a system, and I need a judge or a reward model. There are many different names for this kind of system, and I can use reinforcement learning to fill in the rest. You don't need to give me a bunch of labeled data. Getting labeled data is really hard for humans, but getting a judge is not that hard. And we took a lot of time to figure out what was easy and hard for our customers to get, how we could do the science to make it possible to customize an LLM using that data, and you've got Agent Bricks.
And you're scaling essentially reinforced learning through this. This is what I'm hearing.
Yeah, is that right? This is reinforcement learning for everybody.
All right, so let's get into the conversation we had a couple months ago. I was riffing with you, I'm like, hey, how do models talk to each other? Do I do a small language model? Can I just distill off of a large one? And I can just see you busting out. Wait until data plus AI. So one of the things is model integration. We heard Jamie Dimon basically saying, I'll use a small model right here, but I still am going to do a lot of other things. So this model integration should be seamless. Where does this all fit in? How does that play into the system that you built?
So I think there are two key aspects to that. One is, how do you get the model you want in the first place? And that comes down to things like TAO, our test time adaptive optimization, this reinforcement learning technique, which just makes it easy to get what you want. I don't want you to have to labor and label 10,000 examples, and I don't think it's necessary anymore based on the technology we built. And the second part is, how do you orchestrate all these models together? Well, we spent a lot of time thinking about that, and that's where we have our multi-agent, Agent Brick. That brick is all about orchestrating all the agents that you build with AI Builder, or with our Agent Bricks, and everything that you build outside of Databricks as well, and getting that to all work together seamlessly. It's going to be, in the same way you don't have one human who you say, can you go and do the research, and then can you go and write the report, then go and do the financial calculations, and go and implement the software. It's not going to be one human, it's going to be a bunch of specialist agents, and you have to get all those to work together seamlessly.
The agents actually pull it all together on the models that are needed at any given time, based on the generative process. Orchestration is another hard problem you guys solve, so orchestration and labeling seem to be solved. Is that right?
Well,
or not solved, but pain was taken away.
I would say
how would you describe it?
I would say we've taken a big step toward getting AI ready for the masses. And by the masses, I mean, everybody you see around here. AI used to be the province of the hyper-advanced Databricks customers, the people who had PhDs, the people who were, willing to take some risks and willing to put themselves out there, try a bunch of things and fail, learn about a new technology. And now, I think pretty much anybody who we see in this massive room, probably, thousands of people who are in this room right now, could go and use Agent Bricks today and go build an agent, and I'm really proud of that.
You should be. It's a great enthusiasm is high. Obviously, I love it. Now the next step is confidence. So once you hit enthusiasm on the attitudinal scale, you're only one step away from the solution, which is confidence. So how do I have confidence if I'm a builder and I have an Agent Brick? I'm just like, okay, how do I tune my agents? Now these new things come up. Take me through the learning progression of a customer, or what they should be leaning into. I want to be an AI engineer. I want to be fluent in tuning, how-tos, because that's where confidence kicks in. The judges help, the mechanism, but the human piece becomes key, the builders. Yeah. Take me through the progression.
So I think for the builders, what I would say to all of them is, honestly, I'm going to sound like a broken record. 2025 is the year that AI engineering replaces AI vibes and AI demos. there's a practice to this.
Yeah.
There are concrete techniques, behaviors, patterns that if you follow them will lead to better outcomes. In the same way that we do software engineering in a very careful way. We write tests, we have functions. Someone had to invent the while loop. There used to be the go-to statement that would just jump all over the place. That's kind of AI in 2024, AI in 2025. There's a real practice and rigor. And Agent Bricks is meant to kind of, in some sense, teach you how to do that by holding your hand and forcing you to do the things that we think are the best practices.
All right, so 2024 was the summer of AI vibe love.
Yep.
And 2025 is the engineering love.
Yeah, I think this is, I'll give you the metaphor, which is like, if you want to go build a bridge and you just kind of build it out of mud and, you say, the vibes feel good, I went and walked on this bridge and it feels pretty solid. That's one way to build a bridge. Another way is to say, here's the load that my bridge is going to need to take. Here are the seismic conditions and the weather conditions. Here's how long I want it to last before it'll be repaired or replaced. Here are the materials I think are going to be able to support this load. Let me 10x the load just to be safe. And then I'm going to build a bridge and I'm going to feel great and have confidence. There's a process to doing this stuff. And I think we're getting there with AI.
Jonathan, I think you're right on. In fact, all the CISOs and CIOs or leaders at large enterprises that I talk to on theCUBE and also privately all say the same thing, certainly in the financial services. They've been using machine learning for decades with fraud detection. Gen AI, there's a high bar. So this they want to hear loading, trust. They want to hear these key words because they want to test. They have to have zero downtime, zero hallucinations.
No, zero is always a hard thing. Bridges do collapse. They happen rarely, and we learn a lot every time this happens, and we don't make the same mistake again.
We all been to that. We all have seen that physics movie in class where the bridge is on the wrong frequency, the swaying bridges and the amplitude.
We learned a lot from that. I'm a Marylander. I saw the Francis Scott Key Bridge go down earlier this year, and that was tragic and scary, and we learned a lot. But I'm going to use one word for you, the word that I think every C-suite person who's thinking about Gen AI right now should hear and should ask everybody: reliability. How is it that I can build AI systems that will be reliable? Not the bridge built out of mud that's going to melt the first time it rains, but a bridge that is built out of steel and concrete that is going to be there, season in and season out for decades to come. How am I going to build an AI system that I don't need to rebuild in 6 months? And reliability, it's evals, it's measurement, it's engineering, it's reliability.
Yeah, and also creating a foundational baseline for headroom for more features, more agents, because there's more coming. What's your view on that? As you get a trajectory, this flywheel of observability meets management, understanding and measuring the agents as like labor or as human assistant, what's next? How do you usher in? What's the headroom look like in your mind as you think about what's coming, where you are today? What's the headroom?
So the headroom is enormous if our practices get better. So I've actually, this is going to sound really weird and philosophical. I've been spending a lot of time reading about computing in the 70s. Now, I don't remember much about computing in the 70s, but if
punch cards.
If someone wants to go and read one really interesting thing from the 70s, Edsgar Dijkstra's Turing Award address from 1972. It has some great quotes about this thing called the software crisis, where, from what I understand from reading then, we built these massive software systems. We didn't have a ton of best practices for how to do it in a modular, reliable way, and things just collapsed. Software wasn't able to hold up and we couldn't fix it. We didn't know how to debug it. It was a mess. And he has this great statement in his Turing Award address. I'm going to butcher it, but basically, when computers were slow, software engineering didn't really matter that much because we couldn't do much to begin with. But then computers got fast and we could be ambitious. And these poor programmers not only could be ambitious, but their CEOs were asking them to be ambitious and they didn't know what to do. And out of that crisis emerged the modern practice of software engineering, loops and modules and classes, object-oriented programming, testing, everything
data
that we
structures, everything we know.
Everything showed up from the crisis of that era. And for me personally, I'd rather learn from history than repeat it. I think a lot of people are on track to repeat history right now with AI. Instead, if we do good AI engineering, we make it modular, we make it reliable, we do evaluation, we're going to be able to build big AI agent systems that will stand the test of time starting today.
Yeah, I totally think you're right on. If you're a student of history, I would also say if you look at like 1980 to 85, there was some really great computer science theory around OLTP. You mentioned native, you guys have native OLTP, hold on to the story, but also compiler theory, autonoma, and also discrete math. at that time. And the first OS book, I forget which one it was, really talked about things like locking and like understanding these but they were not a lot of algorithms. It was pretty basic.
Yeah.
It was like, but they were hardcore.
Yeah, if I had been around then, we'd be calling it Frankle's algorithm, because I would have been, one of the 5 people who cared about this and worked in it. It wasn't complicated, but someone had to identify what the problem was, describe it clearly, and then find the solution. And it's identifying the problem and describing it that's the hard part. And here we have it. It's measurement and modularity of AI agents.
Jonathan, I love the computer science rebirth or renaissance, because up until this year, I've done theCUBE for 15 years. I've covered a lot of events, a lot of the mainstream tech events. This was the first year, actually last year was the first year, I've heard the word computer science on stage. Jensen Huang must say computer science at least 3 times. Their computer science is back. I mean, not that it ever left, but I think it's much more mainstream in the nomenclature of the industry. It used to be like, okay, computer scientists would do things. You had software engineers, then you had developers and coders. Software engineering was a word. Software engineering. Then it became developers. Then it became coders. We're back to engineering and kind of OS design.
Yeah,
it's interesting. I mean, even enterprise solution architects have to become systems architects.
We're all scientists now. AI, you don't build AI like you build software 1 line of code at a time. You build AI by trying to build an agent, measuring it, having hypotheses for why it didn't behave the way you wanted, rebuilding it, measuring it better, and repeating this process. That's science in the purest sense of science. And I think you're hearing me dig deep into the history of computing to pull out these ideas that I think are going to come back. I think all of us who are trying to figure out what to do with this stuff are going to have to look back at our history and remember those books we read when we were in school. And again, if we don't learn from history, we're doomed to repeat it.
I mean, that's a great point. What to do? We're all scientists. Jonathan, always great to have you on theCUBE, and congratulations. It's out there. Final question for you. What are some of the Slack messages you're getting? Take me through what's going on in your life right now, today, as this was blowing up for you, as you celebrate and also lean into all the inbound comments. Give us a taste. What's the sentiment? If you had to do a tag cloud, or if an agent could assess what's going on, what would it tell me?
I think there would be 3 words that would really stand out. Number 1 is customers, number 2 is customers, and number 3 is customers. All of my customers, my favorite people in the world, are here. And they're the customers who helped us develop Agent Bricks by working with us over the past year and kind of helping us find the patterns. I get to go and hang out with them and tell them, like, thank you for working with us. You got it a year early, and now we've got the real thing. And then there are all the new customers I'm getting to meet, and I'm getting to say, here you go. It's time to take these lessons we learned and give them to everybody that you see behind you. So it's all about the customers at Databricks, and I can't wait to share this with them.
You're going to be super busy in the next couple of months, second half of the year. Now it's time to celebrate, as they say, celebrate the moment and move on to the next level.
The way you celebrate the moment is you go and help the customers be successful, but the other way of looking at it is, Data and AI Summit is our Super Bowl. You know what happens after the Super Bowl? Your record is 0-0, and you get back to work at the beginning of the season, and you start developing everything for next year. So I'm excited to get back to work.
Congratulations.
Thank you.
All right, the man behind a lot of the action and all this time spent on judges, all the work going into evaluate credible, reliable agent platforms. AI engineering is the year that's upon us and will be, as AI engineering takes a lot of the same paths as software engineering took in the old days. As we look at what to do next, the future is unwritten. Of course, theCUBE will be doing its part and sharing the stories with you. I'm John Furrier, host of theCUBE. Thanks for watching.